Hello, my name is Wim van Leeuwen. I'm an associate professor in the School of Natural Resources and the Environment, and I also have a joint appointment with the School of Geography and Development. I'm also actually the director of the Arizona Remote Sensing Center, which is where I spend most of my days working in the lab and also doing some field work off and on. So I'm going to tell you a little bit about my research. The things that I do are related to both fieldwork as well as using satellite data to monitor Earth system processes. And I have about 30 years of experience with remote sensing. The first 15 years as a student, but then later on as a PhD student and a research scientist. I worked on a satellite system called Terra, and on that platform was a sensor called Modus. And that's how I spent my first 15 years almost actually working on this satellite, creating and developing products that actually allow us to observe the Earth using an index called NDVI, Normalized Different Vegetation Index, and it really allows you to look at greenest differences and on the land surface, and also trying to look at how things are changing over time. This Modus sensor was launched in 2000, and ever since then I've been using it to monitor different things and also look at phenology and other natural processes that are taking place. The last 15 years I also got to travel again. It was a lot of fun. I did some international projects with Spain and Israel, and with Spain and Israel we worked on dry lands and arid lands and the issues associated with wildland fire. Wildland fire, again, pre and post wildfire, you can monitor with satellite data, and the satellite data we can download from different sites and then characterize and quantify the amount of wildfire that is there. So some of the other projects I've worked on are related to analyzing time series data. As the satellite is collecting daily data, we actually then create data sets that are cloud-free, and every 2 weeks or so you get a cloud-free image that we then can use to characterize the timing of what's happening on the land surface. We call this land surface phenology. Phenology is about the timing of biological events. It's like the biological clock. And if you have time series of satellite data, we actually can see with the satellite when things are greening up and when things are greening down, when they're browning down, basically the peak of the growing season. And that's really important. About 1 year ago, I started a National Science Foundation project related to assessing the woody cover for Kansas, Texas, and Oklahoma. This is a project where we use a variety of different data sets, from Modus to Landsat to the National Agricultural Imaging Program. We use different algorithms to assess the woody cover in a large region, and this research is done because we want to find out how people are managing the woody covers in response to for grazing purposes, but also for and how they manage it based on using wildfire basically to get rid of the woody cover that's impacting the grazing of a lot of the farmers there. And then some other people want to use it for natural habitat and hunting grounds and things like that. So we're trying to look at the socioeconomic impacts of managing these different woody cover landscapes. A current project that I'm going to start soon is actually related to snow and water resources in the Salt and Verde watersheds for the Salt River project. So that's where we're going to look at snow and water, and look at snow in the wintertime that will actually feed the water and the lakes that provide water to the larger metropolitan area of Phoenix. So we're going to use LiDAR, we're going to use a variety of different data sets for that. Another project that we've been working on is related to a project at Biosphere 2, where there's a poplar plantation, and that poplar plantation we have been monitoring over time, but we're looking at plant physiological processes and how we can relate the plant physiological processes to spectroscopy, or the spectral data that we acquire with different sensors. We also take some temperature data sets at the same time, and we're trying to relate the plant response over time, the different seasons, and how the plant is responding as it gets colder, and how the spectral signatures change over time as well. So for that we also using a drone to kind of also observe the plantation, and with the drone and the camera we can create a three-dimensional structure of the landscape. And that's a methodology that's relatively new, and we also want to apply to the NSF project for the woody cover. So other things that I do is, of course, I teach several classes in remote sensing, the introduction online. I do several graduate courses as well. There's a variety of different topics from land use, land cover change to more the fundamentals of remote sensing. Just today I was out in the field with the students, training them how to look at and measure different things with different equipment. So I hope you enjoyed listening to my research endeavors. I hope this was inspirational to you, and I enjoy it tremendously because I get to be out in the field as well as being behind the computer, bring all these different data sets together. Lots of geospatial research here that we do at the University of Arizona and that I actually bring into the classroom as well. So I hope to see you maybe coming to the University of Arizona and take advantage of all the resources we have here. Thank you for listening, and I'll see you soon.